In this screencast, we are going to go a little more in depth with the VSEPR or VSEPR theory. So the properties of molecules depend not just on the bonding of the atoms, but also on the molecular geometry. So we're talking about the three-dimensional arrangement of the molecule's atoms. You want to remember that in chemistry, we're not talking about things that are two-dimensional. They're not flat. We're talking about three-dimensional molecules. That means they have depth to their shape, and this affects how they interact with each other and their shape. So the polarity of each bond, I should say bond, not bind, but the polarity of each bond along with the geometry of the molecule determines the molecular polarity. So we briefly talked about polarity before. So polarity deals with how the electrons are shared equally or unequally. So the molecular polarity, or the uneven distribution of a molecular shape, affects how the electrons are being shared. The polarity strongly influences the forces that act between the molecules in liquids and solids. And we're going to talk more about polarity in an upcoming screencast. So now specifically to the VSEPR theory. This theory states that repulsion between the sets of valence level electrons surrounding an atom causes these sets to be oriented as far apart as possible. So you want to keep in mind that electrons have a negative charge. Think about when you're playing with magnets. If you have two north poles facing each other, they repel. They don't want to be near each other. They want to be as far apart from each other as possible. Well, the same thing is true with electrons. Because the electrons all have a negative charge, they want to be as far apart as possible. And because of this desire to be as far apart as possible, they cause the bonding electrons to be bent or to shift so that the electrons can be as far apart as possible. And this is what contributes to the shape of a molecule. VSEPR stands for valence shell electron pair repulsion. So the VSEPR theory is the valence shell electron pair repulsion theory. That's what the letters stand for. And the shape of the molecule refers to the position of the atoms only. It can also account for the geometries of molecules with unshared electron pairs. So the shape isn't based just on the electrons that are being shared between two atoms, but also between those electrons that are not involved in the sharing or the bonding. So here in these two examples, you can see we have examples where there are non-bonded pairs of electrons. So on the left, you'll see ammonia, and ammonia has two unshared electrons, so one single pair. And the fact that these electrons are present cause these other shared electrons to bend, to move as far away from the unshared pair as possible. And that causes a bond angle of 107 degrees. Likewise in water, water has two unshared electron pairs. Okay, so that causes the hydrogen atoms to bend away from the unshared electron pairs, giving a bond angle of 105 degrees. Unshared electron pairs repel other electron pairs more strongly than the bonding pairs do. So in class, we're going to talk about different shapes that happen, and you'll notice that the shapes really do depend on, is there a shared pair of electrons or an unshared pair of electrons. In class, we do an activity where we look at the different shapes that can be formed. Some of those shapes include triangular planar, triangular bipyramidal, linear, we have octahedral, triangular bipyramidal, so lots of shapes. You're going to want to refer to the chart that we create in class to look at the shapes that you're responsible for knowing on the test.